Okay guys, today's video is going to be on near field interference, and what I found was when I was hooking up my mobile duplexer that depending on whether I transmitted low or high, I would get a 30 plus dB desense on my receive, and I couldn't figure out what was going on until I started doing some research on it. And what I found is that on every transmitter, there is a region around the antenna where the radiation has not completely formed into its waveform like it's going to be, and there's going to be a lot of like non-conforming radiation in the area to where it produces interference on frequencies higher than the transmitter, and these signals are legitimate signals, and but they quickly attenuate and go away to nothing, and they don't propagate like normal radio waves are. So depending on if you have a receiver within this area, it'll get desensed really bad by this interference. And it's not because of the front end of the receiver getting overwhelmed by RF. It's these on-frequency products. And I can even take a bandpass cavity and a notch cavity, put them together, and actually measure the amount of on-frequency signal being produced. And it's really like an amazing magic trick where the signal just reaches a certain point and it goes away completely. According to the theories and everything, it should only be that noticeable within 2 wavelengths or 13 feet at VHF for this effect. But I've done testing, and I found that a weak VHF signal will get desensed up to 100 feet away from a transmitter, even just 10 watts. And once again, it's not because of the let me pull over here. I can bring this up some more. It's not because of the on frequency or the receiver front end getting overloaded by RF. It is from on frequency interference, and it's a very crisp cutoff. I mean, you can walk with your portable and just you hear it have the person key up the transmitter, it gets taken out, and as soon as you get past this one magical area, it has no effect on it at all. It doesn't desense it at all. So, and these frequencies only seem to occur on the higher end. I'm about to switch to the video where we go out and I'll show you on the spectrum analyzer what it looks like, and then what the how to get around it. But the initial interference is always higher than the frequency. So that's why when I first hooked my mobile repeater up, I was transmitting 159 and receiving on 151, and I had no desense at all, and it worked perfectly. But when I flipped the pairs around, I got huge desense, and this is why. But I have a solution for it, and it involves using a shielded antenna, and I'll demonstrate that. But yeah, I'll let you go into all the information on online about near field and far field radiation. Is not for the VHF world, not for the two-way world. It's more for other like PCB stuff. But the same information applies. But anyway, this is what I've experienced, and like I said, I'll swip over to the spectrum analyzer out in the field, and I'll show you what's going on with that. So stand by. Okay, I want to give a run over of the equipment I'm using here for this demonstration. I have a quarter wave antenna on a sheet of metal here for a ground plane. This is going to be my transmit antenna, and there's many there looking on. This is going to be my receive antenna. It's just a mag mount on top of a toolbox, and it's about, let's say, 15 feet, 20 feet from the transmit antenna. We come over and look what we have. The transmitter is a Kenwood NX700, and it's transmitting on 151.27 megahertz at 10 watts. And my service monitor here on the antenna port is getting fed from my duplexer here. Now the duplexer antenna input is coming from the mag mount. I have a dummy load on my low side, and my antenna port on the high side is coming back in here to the service monitor. So when I key up the radio, the 151 signal will be greatly attenuated through the notch filter, allowing me to see the radiation on either side of it without overwhelming my my service monitor and having it scream at me. So I wanted to show you what the interference looked like in its nature. I'm going to come over here to 151, and I'm going to key up the radio and get you to see there's the center carrier of it. And like I said, if we didn't have the duplexer on, it would be off the charts. So we're going to scroll up in frequency, and we're going to get to 159. Oh, here, let me go 155 so you can see it all in the same thing. And what you'll see is you'll see the carrier to the left, but to the right is this mountain of hump. And it just so happens it comes right across the 159. If I come over here to 159, and you can see there's the mountain hump. And this is what will take your receiver and desense it. This 20 dB worth of noise here. And I'm going to stop the video and reconnect from the service monitor to a portable on the weather channel so you can see it being desensed in real time. So stand by for that.
North winds 5 to 10 knots.
Okay, we're back. We now have the weather channel hooked up here. We're only getting 2 bars on the weather channel, and you'll see when I key up the radio, it completely wipes out the weather channel. So every time I key up, it's gone. And that's the effect. If this was a 159 receiver, it would get the same effect. And even if I put a high notch band pass cavity on it, it doesn't help because it is on frequency product that comes out. So let me switch to the other antenna configuration here, and I'll show you what my solution for this problem is. Okay, I'm back, and I got the antennas or the receive antenna reconfigured, and let me show you the effect here. I got really just a single bar of signal here, and when I key up my Kenwood, it doesn't have any effect on it at all. It's like I've completely blocked out the near field radiation that was getting into it and desensing it, and that's what I did. And let me show you how I did it. Just one of the hokiest things I've ever done, but desperate times call for desperate measures. What I have is my antenna inside a toolbox, and yeah, does it screw up its performance? It does, but it also completely protects it from the near field radiation of the transmit antenna that's just behind it. So what I found was, if I use this basically as a directional antenna, you only get like maybe 8 or 10 dB of loss if it's directly pointed at the transmission source. So if this is my receive antenna, then I'm pointing toward the repeater that I'm trying to repeat from my on-scene incident repeater. All I have to do is have enough signal, and because it's P25 to be strong enough to make it in to get decoded, and then that's all I need, and then the repeater will work just fine. But that's the solution, and I don't see any other way around it other than physically doing vertical or horizontal separation, which is too extreme in the field for a vehicle. So you're not going to be able to do that, but you will be able to place an antenna in a box around the vehicle pointed away from your transmit antenna. And that solved a problem. So like I said, if you don't have any kind of and I'll turn it back around here so you can see it facing the and now when I key up the transmitter, it completely kills it. So anyway, that's my solution to it. If you do find out that you have to transmit high and receive low, that's the solution. All the ones I've done, it seems like all the near field interference is always above, greater than your initial frequency. So, all right, well, that's that, and hope this helps you guys out. We'll talk to you soon.